In this video, I have a brief demonstration and rundown of a couple of the components that I've used to make this calculator in Smart Logic Simulator. So to start off with, I'll just give an overview of the keypad and just show what happens pretty much when you start pressing buttons. So once I start hitting digits on this keypad down here, they'll go into whichever set of these AND gates are primed at the time. So we'll start off with these ones down at the bottom here. Those outputs will go into these orange things here, which basically convert it from decimal into BCD, then into binary. Those outputs will go into the ALU, the multiplier, and the divider all at the same time. And depending on the operation you've chosen, the AND gates here will be selected, and once you hit equals, those AND gates will output the appropriate answer. So if you've selected multiplier, the AND gates associated with multiplier will output once you hit equals. So let's go into the demo, and we'll just start with addition, and I'll just do some random calculations. So alright, and we'll do subtraction. I don't know why I'm doing 250 all the time, so hang on, subtract. And this can do negative numbers as well, so I'll do 17 minus 259. There we go. Now multiplication. And division. Okay, now I'll just go into a quick explanation on how the input circuit works and how not the BCD, how the divider works. Alright. Okay, so what's happening here is every time you push a button, the number is getting converted from decimal into binary and saved into this register here, which then outputs the number as BCD. So for each position beyond the units position, say tens, hundreds, thousands, and tens of thousands, those digits get multiplied by 10, 100, 1000, or 10,000. So we'll input something quickly. So we've got 2,446 in there at the moment. So that's basically getting added back together and being output as binary. So I'll just try and show how this is kind of wired. So each of these is sort of wired to the next one above. So tens and hundreds are being added together, and hundreds and thousands are being added together, and thousands and tens of thousands are getting added together, and then they're getting re-added back together with these lot of adders, and then added into, or back together again into a 16-bit number. And that's pretty much how that works. So I'll just clear this and we'll have a look at the division circuit. So this is the division circuit. Now, as with the input, I had a bit of a hard time finding good information on how I'd go about making any of these components. So for the input, I kind of just had to wing it. I mean, I got the idea to multiply the output from another video I watched. I can't remember who that was by though, but theirs was only for 2 digits, so I had to try and figure out the rest for 5 digits, and that took a bit of time. And for the divider, there's a lot of videos out there for multiplication and addition and subtraction, but there's not really a lot of videos out there for division, so I ended up having to resort to a Minecraft video by a guy called Newomasters, and this is pretty much the design he'd built in that video. So I'll link the video in the description to that divider by him, because he'll do a much better job of actually describing what's going on with this than I will. But it is a very reliable divider, and it can go beyond the radix point. You just don't add, you just add more conditional subtractors, and you don't add any more inputs basically. But yeah, I'll link the video in the description to Newomasters' video about this, because he'll do a better job of explaining it. But yeah, apart from that, thank you for watching.